What's up, you wonderful human beings? Hope you guys are having a great day. Hello, it's me. You want to talk about something cool today? We're going to talk about modeling fractions, okay? The multiplying of fractions, that is. So it's going to be a rocking good time. Just like thinking about this, and it's kind of gross, but like, what has hands but never washes them? That would be a clock. Tick, tock, tick, tock. Never washes its hands. Do you know what clocks are? Probably just the numbers on your phone. Anyways, you used to have hands that would move. I think you get it. All right. So today, like I said, we're going to talk about what it looks like to model the multiplication of fractions so that you have a real solid understanding of what it means to actually multiply fractions before you get to the algorithm or the trick or the easy way through. But we want to make sure you understand it first, okay? So vocabulary time, always with fractions, we want to make sure we understand what simplest form is. Simplest form mean it's the fraction where when the top and bottom cannot be any smaller while still being whole numbers. So basically what that means is if we take this following fraction, simplest form means it's the equivalent fraction that is in its smallest form and kind of easiest to use, right? So if we take this fraction here and we say we want to simplify it, well, you look at it and you find out if there's any common numbers that will go into either one of those. And those are called the greatest common factor. So you kind of take your number and you say, all right, I'm going to take this 8 because that's our top. And what numbers go into 8? Well, 1 goes into 8 because 1 times 8 is 8. And what else goes into 8? 2 does because it's an even number. 2 times what equals 8? 2 times 4 equals 8. Okay? The only number left in the middle between 2 and 4 is 3. Will 3 go into 8? No, because if you count by 3, you go 3, 6, 9. You skip right over it. So 3 will not work. All right? So then we take our other number. And again, what we're looking for is the greatest common factor or the greatest number that will go into both of them. So we always know that 1 works every time. 1 will go into everything. 12 is an even number, so you know 2 will always work. 2 always works with even numbers. So 2 times what equals 12? Yep, that would be 6. Okay, we still got some numbers in between 2 and 6, so we need to just try them. Will 3 work? Let's count by 3. 3, 6, 9, 12. Yeah, 3 times 4 is 12. So now there's nothing left in between 3 and 4, so we're done. Now, is there a number that those two have in common? Yes, and that number is the greatest number they have in common is 4. Okay, so that means we can divide both of those numbers, because we're getting smaller, we can divide both of those numbers by 4. So let's divide the top and bottom by 4. So what's 8 divided by 4? That would be 2. And what's 12 divided by 4? That would be 3. Okay? So now we have our answer in simplest form. Pretty cool, huh? All right. Now, do you guys remember using area models? You've probably done this in a previous grade level, but when you use area models, what we're talking about is multiplication. So what would 4 times 7 look like, all right? I need you to understand this before we get to the fractions because we're going to use area models there as well. So what does 4 times 7 looks like? Well, we put 4 on one side of the rectangle, the smaller side because it's the smaller number, and we put 7 on the other side. And then we said, oh, well, 4 is equal to this, all right? We take that rectangle shape and we cut it into 4 equal rows, okay? And then we do the same thing with a 7. We take 7 and we take that same size rectangular shape and we cut it into 7 columns. So if you could look at it, this has 4 and this has 7, right? So we look at it, okay, that makes sense. And then what you do is you basically put them both over top of the area model and we can find out how many squares we have. 4 rows of 7 columns gives us what? Well, so the amount of squares we have in all is our area, and it's the answer to our multiplication problem. So 4 groups of 7, 28. Do you remember how that concept works? Well, let's see what it looks like in fractions, okay? So what if we had the same idea and we were multiplying fractions, 3/4 times 2/7? Okay, so put up our rectangle, right? And then we're going to take our fractions and put them on either side. Okay, now let's represent this. So remember, when we see that multiplication, we're saying 3/4 of each of the 2/7. That'll make more sense in a second, but 3/4 of, that's what multiplication means, each of the 2 sevens. So let's do it like we did on the last one. So we take these 2 sevens. So notice I did the second fraction first, okay? I did the second fraction first. And so I have 2 sevens. I broke my rectangle into 7 pieces, right? 1, 2, 3, 4, 5, 6, 7. Okay, and then I went ahead and colored in 2 of them, smiley face, because that would be 2 sevens, right? Everybody with me? I hope so. Okay. So then I take the other one and I say 3/4. Well, I cut my rectangle into 3/4, okay, right into fourths, and then I colored in 3 of them, right? So far, so good. So then I do the same thing I did on the other one. I gotta put them both on the rectangle, but I'm doing it to make some sense of something. So here's 2 sevenths. That is 2 sevenths of our rectangle right now. And what we want is 3/4 of each of these. We're going to show all of this stuff, right? We're going to show all that, but we want 3/4 of each of these sevenths. So when the rectangle slides over top of it, you're going to see that the yellow covers a lot of the big rectangle because 3/4 is bigger than 2 sevenths. And you're going to notice that there is places where they both cover sections as well. So let's just see what that looks like. Okay, so when I slide that 3/4 over, what I am saying is I have taken these each of these sevenths and broke it into 3/4. So I did 3 out of the 4. Notice the bottom one's not colored in. And then I did 3 out of this column. Notice the bottom is not colored in. So what we have here is when you place them over top of each other, you can see what 3/4 of those 2 sevenths are. So here's the 2 sevenths right here, right? I'm trying to color that or just shade it in outside, maybe make a little circle there. Okay, those were the 2 sevenths. And then when I brought these 3/4 over top of it, this is the place that shows our answer. So how do we find out what our final answer is? Well, we say how many squares does our area model have in all? That would be the total pieces. So that's the all. And that in this case, it's 28. Just like that last area model because we have 4 rows of 7, okay? So our denominator is going to be 28. And then our numerator becomes the squares that are both shaded in by both colors. So we have none of these are in our numerator because they're just yellow. None of these are shaded in because are part of our numerator because they're not even shaded in. These 2 aren't part of our numerator because they're just blue. These 6 right here is going to be our numerator because that is the yellow and blue together. So our answer is 6 out of 28 or 628. That's how you do the area model. Okay, let's try one more. So let's do 1/2 of 2/3. All right, so here's our rectangle. We go ahead and put our sizes or our fractions on each side. And we remember to ourselves that we're talking about of each. So what we're saying is we want half of each of the 2/3. So let's go ahead and look at our 2/3. We do that first. And what we're saying is, remember, we want half of each of those, okay? And so then we go ahead and put our half over here because that represents half of the rectangle. Okay, so if I put my 2/3 up here, I want half of each one of those. Okay, so when I slide my half over top of it, you see that now I have half of each of those 2/3. So what's our answer? How many squares does our shape have in all? Well, that would be 6. Okay, and then how many of them are shaded in by both? That would be 2. So our answer is 6. Okay, and if it was 2, 6, we would have to ask ourselves, let me do it right over here. So if it's 2, 6, we have to ask ourselves, is that in simplest terms? And it's not. Let's what numbers go into 2? That would be 1 and 2. And what numbers go into 6? That would be 1 times 6 and 2 times 3. What's our greatest common factor? 2. So 2 will go into both of these. So 2 divided by 2 equals 1. And 6 divided by 2 equals 3. So our answer, 1/3. But to model it, this is the most important thing we're talking about in this lesson, okay? Okay, so now we're going to show this on number lines. Okay, so we multiply by number lines. This is what it should look like, okay? We're going to go and put our shapes on a number line. So let's do that. Let's go ahead and say, first we have to break our holes into 4. So our problem is 1/3 of each of the 3/4. So what we're going to do first is break those into fourths. So break our number line into fourths. So let's do that. Here we go. All right, do you see the fourths on the number line? We have 1/4 plus another fourth plus another fourth and another fourth. All 4 of those fourths will make a whole, right? Then what we're going to do, second thing we're going to do is we're going to break each of those fourths into thirds. So that's what we do. We get with our handy dandy computer here, we break each one of those into thirds. So now we have our fraction, our number line, our one whole broke into fourths, and then we broke each of those fourths into thirds. What happens next? Well, we need 1/3 of each of the 3/4. Let's say that again. We need only 1/3, because that's the number we're multiplying by, of each of only the 3/4. So what does that look like? It looks like this. Remember, this is a third, and a third. And we only need one of them. So we need the first one, and this is the fourth, right? So then we need the one of the thirds of the next fourth. Okay, and then we need 1/3 of the next fourth. Notice that we didn't put one there. Why did we not put one there? Because we're only doing 3 of the fourths. So then once you do that, you figure out, well, how many total parts do we have? All right, let me erase my writing so it doesn't mess with it. How many total parts do we have? Okay, we have 12. That's our denominator. Okay, and right here tells us our numerator is how many of these did we bring down on our number line. We brought down 3. So our fraction is 3/12. We could simplify that by saying, what are the factors of 3? Factors of 3 are 1 times 3. And then what are the factors of 12? Factors are 1 and 12, 2 and 6, 3, 4. So 3 works. And a rule of thumb is if the top number will go into the bottom number, just use the top number. So 3 divided by 3 is what? It's 1. And then 12 divided by 3 is what? It's 4. There you go. So our answer is either 3/12 or 1/4. All right. I think you guys are ready to rock and roll. So, what kind of driver never gets a ticket? What kind of driver never gets a ticket? A screwdriver. Screwdriver, it's just a tool. It's not going to be driving anything. Hey, have a good day.